Welcome to Data Skeptic K-means clustering, the podcast exploring the problem, the algorithms, enhancements, and use cases for K-means clustering. If you heard last week's episode, towards the end I was cautioning Linda about blindly using K-means singularly as a technique for partitioning your customers into groups. Done blindly, that doesn't make a lot of sense. Accomplishing such a goal in a meaningful way takes precision and an investigation of other metrics, algorithms, and approaches. In this episode, I speak with Ehsan about his research into clustering bank customers.
I'm Ehsan Barkhordar. I'm 26 years old and I'm now a data scientist at market.com. Actually, I acquired my master's degree in computer science from American University of Technology. My research interests are mainly in customer and market analytics, time series analysis, computer vision, NLP, and so on.
What are some of the types of questions that are interesting when you look into customer analytics?
It's a general question, so it doesn't have any definitive answer. Sometimes it comes to my mind to talk about time analysis when you are doing some research about, using some data to predict something, and for some clustering purposes, maybe some NLP tasks.
What are some of the types of questions that are interesting when you look into customer analytics? For example, when a company wants to cluster their customers, what is the purpose? What do they want to do with the clusters?
If you're working in a bank or a financial industry or something like that, you're worrying about how to create a service for new customers or how to keep your customers satisfied with everything you have in your industry or in your company. So it's really important to be updated, to have some tools to extract the information from the customers. For example, you want to know what types of customers I have or how they can interact with each other or how they move from one type or one group to another group, actually transmitting. And these informations are really important when you want to making some decisions. For example, you're a manager, you want to invest on a new startup or new tools, and you want to make a big decision for creating a new service. Okay, so it costs a lot. So you should be careful about your decisions. In this time, the data and the clustering helps you to have a bird's eye view from the customers and make efficient decisions about them. For example, one types of customers are really worried about their balances or the loan or something like that. And you should decide for them, and you need some information about them. For example, the monetary, the frequency of purchases or something like that. That's it.
So I think you're describing some of the feature engineering steps, I guess. Is that a good way to look at it?
Yeah.
What are some common types of features? And I know the paper is all about the banking segment, so maybe we should talk about banking customers. The last time I signed up for a bank, I gave them my name, my address, my social security number, and a deposit. I don't think I told them too much more, so it seems like they have limited data on me. But I still have that account after a year. There must be something there. What can you featureize about me as a customer?
Actually, there is two types of information and features. The first type is about the dynamic features from a customer. I mean, purchases, loan payments or something like that, which are dynamic and change during the time. And the second group are the static features, your gender, sometimes your age, because, it changes during a year. It's not dynamic. And your location maybe, or something like that. Okay, so at the first stage, it seems there is no plenty of information about you. But of course, the financial information matters. It's really important because it relies on your social activities. It relies on your financial issues and everything. Okay, so for example, when you purchase a car, it means you have enough money to invest on something else. Okay, if you purchase a cigarette, okay, it means you smoke. Okay, so there is no need for more information, the personal information And the financial transactions actually are really meaningful information.
And let's talk a little bit about the architecture you worked on. What did you guys build this with, algorithmic-wise?
This paper have two parts. Okay, the first part is about the neural network and LSTM-based encoder and decoder. And the second part is about dynamic time warping. And I think many people these days are interested in neural network approach because they are new, they are trend. And in this paper, we are using them for selecting features, for extracting some hidden information from the transactions. I mean, the bank transactions. And there are some steps to extracting information and then training on them and then validating. At the end, we visualizing or something like that, because it depends on you on the dimensions. It's really important to visualize on 3 or 2 dimensions, and it's not possible to visualize n dimensions or 100 dimensions. And finally, some insights comes to you and you should decide on them. And you said it's a good clustering. I'm looking for this. And so at the first stage, I found a data set. It's from Baraka banking system. It was in a paper in 2000. And, this data set is really good because it's realistic. There is a bank in some country, and they found some information by permission and convert those data into data set. And after finding a proper data set, I was able to use them in order to make a prediction. Actually, it's not a prediction, it's a feature extraction. If you're familiar with autoencoders are neural networks that have the same input as the output. So in the middle, actually in the latent space, the encoder output, it has a lower dimension rather than the input. Okay, so it means you can use this information to actually select some good features for customers which are looking for. And what is the role of dynamic time warping in this paper? Actually, dynamic time warping is a measure. It measures the dependency or similarity of two time series that may differ in time for time series. And in this paper, we are looking for a distance matrix between the purchases. Actually, it shows us the difference between the types of purchases, how they similar to each other or how they differ from each other. And after analyzing these time series, we have some features. So we have 2 algorithms in our paper. First is the LSTM autoencoder, and the second is dynamic time warp. And we combine these features by some special methods, and after that we use PCA or some other algorithms to convert them in the lower dimensions and use them for clustering at first, and after that visualizing the results.
What do you find when you visualize the results?
Sometimes it's really obvious. You're looking for something which is meaningful. The clustering is a technique to find some relations or similarity between types of people or types of customers. So at first, when I've used visualization for conclusion, I found that the autoencoder, LSTM, and the dynamic time warping, both of them were good, but they were not enough. They didn't visualize a meaningful picture from the customers. So I thought that it's a good idea to combine them, to use them in a hybrid approach, and it works. After using some of them, actually combining the features, I found that the final result is significantly better than the individuals, time warping and LSTM-based autoencoder. And but it's not important to use different methods. For example, there is no significant difference between k-means or k-medians. Do you know why? Because if you have enough information about your customers, okay, you can cluster them. But if you don't pick up some proper features, you are not able to cluster them, even with some, complex clustering algorithms. So I don't care about the clustering method because it's really important to select good features.
Thanks to our sponsor, ClearML. ClearML is an open source MLOps solution users love to customize. It helps you easily track, orchestrate, and automate ML workflows at scale. Machine learning is no fad. Your organization is only going deeper on investment. Don't let this be a source of technical debt. ClearML can improve every step in your ML workflow, making it a tool loved by data engineers, ML engineers, DevOps people, and data scientists alike. ClearML is hands down the best collaborative ML tool with full visibility and extensibility. As a contributor on a machine learning team, ClearML amplifies your efforts. As a manager, ClearML gives you the transparency and metrics to guide your team's efforts effectively when you can't get pulled into the weeds. Their solution logs your entire process. Your data and models are versioned, so there's no questions of provenance or audits that can't be done. Model repositories give you a clear view of available binaries, and you can deploy pipelines directly from code. Supercharge your entire development process. Go check out ClearML today. Visit clear.ml to get started. Thanks to our sponsor BB Edit from Bare Bones Software. If you're a Mac user and you have any need whatsoever for a text editor, which, let's face it, that's got to be all of us, you have got to check out BB Edit. BB Edit 14 provides Mac users the most powerful, professional-grade text editor around. It's known as capable and rock solid, and can process files that are large enough to bring other editors to their knees. This tool's been beloved for over 25 years, and I can understand why. If I'm just typing up some simple hello world, I guess any text editor will do. But when I really get into the weeds and need to do some data processing, maybe I've got a big messy file, I need to find all the non-ASCII characters and remove them, BB Edit's there for me. It has best-of-breed multi-file search and replace and great scripting support for text transformations. There's a whole menu of text transformations that you'll find handy. If you're a serious data scientist or software engineer, you're going to bump into situations where you need a powerful text editor. So download and try BB Edit today. You can get it at www.barebones.com. See how much your productivity can increase. barebones.com and download BB Edit. So when I think about LSTM, my context for it is always how it gets applied in natural language, where it makes very intuitive sense, right, that I might mention something and then ramble on a bit, but you still have the context. And when I try and map that to the transaction data that a bank has, I can definitely see where there would be patterns. Maybe it could learn my monthly spending pattern, or my spending pattern might be weekly, some people's monthly, that there are these time-relative features that could come out. I'm less clear on what dynamic time warping does in terms of feature engineering. Could you maybe go deeper into the method and how it reveals something useful for doing the clustering?
Actually, I want to add some information about LSTM. You said, the LSTM networks or some other networks which are really similar to LSTM are used in translation, tasks or, NLP subjects. And it's true. But, there is a same idea between the translation and my work. Actually, I'm translating purchases. And what does it mean? Actually, I'm looking for predicting purchases. Let's give an example. For example, you have 10 purchases. You mask one of them or you put them into the neural network and ask the network to predict, for example, the next one, the 11th. And in this way, the networks tries to actually predict based on the previous knowledge. And in this way, it is trained by the purchases or transactions. And, it's the same as in the translations of, a sequence in English to French. So it's sec-to-sec model, actually. And it's autoencoder also, both of them. It's sec-to-sec model and autoencoder. Autoencoder because the input, the output are the same. And sequence to sequence because we have a sequence of transactions. So it's really good to use LSTM. And actually, I want to add for future works to use, for example, transformers because they are actually trend these days and everybody uses them for, translating text. And I think it works, but In this paper, I don't use them. So I use just LSTM. And about dynamic time warping, actually, it's an old technique. It's not new, but it has a very important feature. It relies on the differences between the time series. So we can infer some new information. We can get some new features from our data or combine them with the previous features. And it's a kind of technique to you make your features stronger, and more meaningful because you use them from two separate algorithms. And yeah, both of them are good, but each one can focus on some aspects of data.
And when you look at the results you're getting back, can you think of ways that the bank might make them actionable? What could this lead to? Is it for promotion or better customer service? How can they use the insights?
At first, it's really important to have enough data. I'm sure the banks have enough data about their customers, especially transactions. And, actually a strategy to use some simple insights in business. What does it mean? You can use some, for example, there is 3 types of people in my insights. So I should find the relation between these types of persons or these types of customers. And in the next step, you will use some other techniques. It's not enough to use just one clustering and that's it, it's finished. No. You should use other techniques, for example, churn prediction to predict your customers when they are churning, actually, or cohort analysis for other informations from your customers. But at first, you want to have an overview on your customers and you want to make a decision based on the types of the customers. So you need to cluster them. So it's really important to cluster them because it's unsupervised learning and there is no previous information. It doesn't require, a background from the customers and there is no need for labels. And it's really good for the initial steps. But after that, you need to acquire new methods or new analytics to get better insights.
So if I understand correctly, your clustering effort was really on a latent space or maybe the feature space produced. And if it's produced through things like PCA and the deep neural networks and things, it's often the case that latent space isn't very interpretable. I don't know what the numbers mean. Did you find that to be true here?
Actually, I think it's better to see the result in clustering. It's really hard to predict the model, the neural network model, and say, okay, there are good features. There is no definitive answer or there is no clear boundary between good features and bad features. If you can use them in a clustering and the result is meaningful, they are good features. So actually, I found it a special point I want to tell you. That is that a low error does not necessarily lead to high clustering performance. It means sometimes you have a higher loss, but your performance in clustering is much better than the previous ones, okay? So actually, I had to use some clustering evaluation methods like CHOOT or some other methods to evaluate my features, my proposed algorithm.
Could you expand upon those metrics? Tell me what you used and how you looked at them.
When you are solving unsupervised problems, you should consider some hyperparameters, for example, the number of clusters or, some hyperparameters in a model. At first, I really suggest that people should care about them. And, it's really a test and train procedure. You should test it on your data. It depends on your types of data or, your techniques maybe. And in my work, actually, I've used k-means because it works well. I used k-medians, but it wasn't really good because it uses the medians, but actually I was considering the mean is more important for me in this work instead of medians.
And do you have any insight as to why that's the case? To me, the median being the, typical 50th percentile customer, I often find it's more resilient to outliers. And when I think of a bank, probably most people have an average amount of money and a very tiny have a huge amount of money, huge number of transactions. What about the mean? Or is there any insight as to why the mean was useful?
You are right, because sometimes the techniques is really rely or outliers. It has some different results when you have far outlier in your data. You should consider about it. But if I want to choose between some, for example, methods in clustering, I will choose density-based clustering methods. Do you know why? Because it's really important in a bank industry, because the information in bank industries are really dense. I mean, it's really hard to separate data because the number of customers is really high and many customers are similar together. Every day they, for example, buy sandwiches. All of them are like each other. Some of them use, for example, buy some tickets in the Sunday, so they are similar together and there is no clear boundary. And sometimes when you are using k-means or k-medians, you're gonna choose a wrong way to cluster your customers, and sometimes it's better to use density-based algorithms. And if I had enough time to use other techniques, okay, I think it was a good idea. Actually, I put them in the future works, for example, to use some other techniques for clustering. I think it's really good, but not just k-means and k-medians. They are really, really limited and they have similar results in the most of the cases.
Makes sense, yeah. Well, is there anywhere people can follow you online?
I prefer to use emails or sometimes Twitter, LinkedIn, for example. Yeah, I have no problem with all of them.
Thank you so much for coming on Data Skeptic.
That concludes another installment of Data Skeptic K-Means. Thanks to our sponsors today, ClearML, BB Edit by Barebones Software, myself, Claudia Armbruster, as associate producer, Vanessa Bly, guest coordinator. Our show notes are written by David Abembe, and our host, Kyle Polich.